So let's get started. Now we are going to look at 1. Safety margin for sizing the contactor. 2. Standard type of contactor to purchase using the utilization category. Contactor sizing. Before we size the contactor, there are certain parameters you need to consider. One is full load current, or FLA. Full load current is the current rating of the squirrel cage induction motor, usually located on the nameplate of the 3-phase squirrel cage induction motor. Okay? Now, this is the nameplate of the 3-phase squirrel cage induction motor. So now we are going to look at the full load amps, or the rated current of this motor. Alright, so on the nameplate you have 52 amps. Alright, 52 amps. This is the full load amps of the motor. Alright, okay. And also we need what you call contactor sizing factor, CSF. The contactor sizing factor is a margin that is applied to the current rating of the motor in order to enable us determine the suitable size of a contactor. There are 3 main margins or ranges that are used to determine the size of a contactor, and out of these 3 we will consider the most preferred margin. Okay, 1. We are going to use 100% margin. Alright, size is equal to FLA times 100%. So this 100% would be our margin multiplied by the full load amps, or the full load current. Okay, with a full load amps of 52 amps from the motor nameplate. So let's look at the nameplate of the motor, the 52 amps. We are going to use this 52 amps to multiply by the 100%, okay, to get our sizing, to get our size. Alright, size is equal to 52 times 100%, and we know that 100% is equal to 1, because 100 over 100 is 1. Size is equal to 52 amps. Alright, now let's look at the contactor ratings chart. This is the current rating of the contactor. Alright, the standard current rating of contactors. Okay, now we got 52 amps from our calculation, so we are going to look out for a number that is a little higher or above 52 amps, and that will be 65. Alright, so therefore size of contactor is 65 amps. Alright, now let's use the 125% margin. Okay, size is equal to FLA times 125%, with the same full load amps of 52 from the motor nameplate. Okay, size will be 52 times 125, and then 125% is equal to 1.25. Alright, so size is equal to 52 times 1.25. Size is equal to 65. Now let's look out for a number from the contactor ratings chart, okay, that is a little higher than the 65. That number will be 70. So therefore the size of the contactor here is 70 amps using the 125% margin. We are using 150% margin. Size is equal to FLA times 150, with the same current rating of 52 amps. Our size is equal to 52 times 150%, and we know that 150% is 1.5. That is 150 over 100. Okay. Size is equal to 78 amps. When you multiply 52 by 1.5, we get 78 amps. From the ratings chart, okay, we are looking out for a number which is above 78 amps, and that number will be 80. Okay, so therefore the contactor size, all right, is 80 amps. So now when we are to purchase these contactors, okay, you can use 65 or 70 amps or the 80 amps. Okay, all right. So now we are looking at the safety margin or factor. Safety margin or factor mostly preferred is 150%. That is 1.5. What it means is that when we calculate for the size of a contactor, all right, we have to use 1.5. That is the mostly preferred factor or the value or the margin. Okay, why? Because this margin is selected so that the suitable size of the contactor will be enough to withstand any inrush current, high overload, and other transient conditions that may occur while the motor is started and running without the contactor load contacts getting bent. What it means is that in order for the contactor to be able to withstand these conditions, that is the high inrush current, high overload, transient conditions, and other conditions, okay, the size of the contactor should be enough to withstand this, because when we use the 1.5 margin, you are going to get a value higher than using 125% or the 100%. Okay, let's continue. Now we are coming to see the type of contactor to purchase. All right, before you purchase the contactor, after performing the calculation, you consider what we called utilization category. Utilization category is an IEC term used to describe the specific type of application of contactor in a specific working space or environment. What it is talking about is that after getting the size of the contactor, so now we are using the 1.5 margin, okay, and with the 1.5 margin we got 80 amps. All right, so now we know our size of contactor to be 80 amps. Okay, it is now left for us to go and buy that particular contactor, and they are telling us that for us to be able to know a particular type of contactor, okay, we use what we call utilization category. Okay, let's see here. Now we see this chart. Okay, this chart here, we have the utilization category. It consists of AC1, AC2, AC3, and then AC4, AC15. Okay, let's look at the definition. We have the resistance furnaces. It says non-inductive or slightly inductive loads, resistive furnaces. When you look at the AC2, the AC2 says slip rings. All right, starting and stopping of running motors. Let's look at the AC3. The AC3 says that squirrel cage motors, starting and stopping of running motors. AC4 says that same squirrel cage motors. The definition says that starting, plugging, and engine. Plugging is understood as stopping or reversing the motor rapidly by reversing the motor primary connections while the motor is running. Inching or jogging is understood as energizing a motor once or repeatedly for short periods to obtain small movement of the driven mechanism. Let's look at the AC15. It says electromagnet. The definition says electromagnets for contactors, valves, and then solenoid actuators. Okay, so now the standard category when purchasing or buying a contactor is the AC3. AC3. That is the most preferred category when you are buying a contactor for squirrel cage induction motor. Because AC3 is for starting and stopping of running motors only. That is the squirrel cage motors, starting and stopping of running motors. But we also have AC4, squirrel cage motors. But this one, it is for reduced voltage status. That is the inching. We talk of inching. Alright? Yes. So the preferred category is AC3, squirrel cage motors for starting and stopping of running motors. That is the preferred category if you want to use the contactor on squirrel cage motors. Yeah. So let's look at this contactor. We have the chained contactor here. This contactor is 25 amps. That is NC1-25. The 25 means it is 25 amps. And now let's look at the utilization category. It is AC3. That is the utilization category for this contactor. It means that they used this contactor for squirrel cage induction motor. Alright, that is why they bought a contactor of AC3 category. So this is so simple. So engineers, we are done. If this is the first time you're watching this channel, I will urge you that you subscribe to this channel. You hit the bell icon, and then you like the video, you put down your comment, and then you share the video to your friends. I will see you in my next tutorials. Thank you.